So here's another example of a wind speed problem. And wind speed and current problems, when we're going down a river, up a river, are very similar problems. So let's take a look at what this one talks about. Against a headwind. So we're going against the wind. Jeff computes his flight time for a trip of 2,900 miles at 5 hours. The flight would only take 4 hours and 50 minutes if the headwind were half as much. So this is a little different than the other type of headwind and tailwind problem, because we don't have a tailwind. We just have two headwind problems. So he hasn't gone the distance, but he's computing his flight time with a headwind for both times. It's just that one time it's half as much. So let's start with the regular headwind. And remember, headwind means against. So let's use W for the speed of the wind, and since we're going against, we're going to have a minus sign. And so that's part of it, but then we have the next equation is going to be half the headwind. So half headwind. And if we're going half the headwind, well, what do you think that's going to be? Well, that would just be 1/2 W is what we're going to end up using there. But remember, anytime we've got a headwind, it's always going to be against, which means it's a minus 1/2 W. We're going to use that in the rate portion of the problem. So remember, the equation goes D equals R times by T. And so when we go ahead and set it up, let's start with the distance. So notice the distance is over here, 2,900 miles. That's our distance. Now, when we are doing it both times, doesn't matter whichever trip we're doing, we're still going to go that 2,900 miles. So we have 2,900 for both of them. So the rate of the plane is something that we're supposed to find. That's what they're asking for. Plane's airspeed. We don't know what that is, so let's call that R. So since R has to be a bigger number than W, because if it weren't, then we're going against the wind. If R was slower than W, we'd be going backwards. So since we're not going to be going backwards, that means R has to go first. So R minus W is the way I write that, because we're going against a headwind. And anytime you've got an expression in one of these parts, either the rate, time, or distance, put it in parentheses. It took 5 hours to do this trip, so let's put 5. Now for the next one, it said, well, it only took 4 hours and 50 minutes if the headwind were half as much. So we still have the rate of the plane, still R, but now it's minus 1/2 W. So that goes in parentheses, and it's 4 hours and 50 minutes. So if you ever have minutes involved in the problem, we have to change that to hours. And the way we do that is just write it as a mixed number. 4 and 50/60ths. 60ths means 60 minutes in an hour, so this gives you the part. Well, from here you could cross off these zeros and just have 4 and 5/6. So let's go ahead and rewrite our problems here. 2,900 equals R minus W, and then times by 5. And then over here I'm going to rewrite this as 2,900 equals R minus 1/2 W, and then multiply this by, now I'm going to change this to this mixed number to an improper fraction. So it's 24 plus 5 makes 29/6. So what I'm going to do, again, when they're doing these problems, they usually work out fairly cleanly, and this one does as well. So I'm going to get rid of that 5. I'm going to multiply by its reciprocal on both sides. So 1/5. Do the same thing on this side. For this problem, I'm going to multiply by the reciprocal of 29/6. 6/29. Do the same thing on this side. And let's see what I come up with. When I do 5 into this number, I know it goes in there because 5 goes into any number that ends in a 0. So 5 goes into 29 5 times. And we're left with 4 left over, so 5 goes into 48 times, and then I have to bring down the 0. So I now have 580 equals, and that would be an R minus W. Now this one's even easier. 29 goes into 29 100 times. 29 goes into 2900 100 times. 6 times 100 Multiply these two numbers, and that's how I'm getting 600 equals r minus 1/2 w. And that makes the problem a whole lot easier. Well, I can't quite cancel out the r's yet. So we are supposed to find the headwind and plane speed. So I'm going to go ahead and multiply, let's do this top one here, by a negative. So multiply it by -1, all the numbers there, and we'll get the r's to cancel. So it becomes negative 580 equals a negative r plus w. And so when I add these together, I do the subtraction here, I get 20 equals, and then 1/2 from 1 makes 1/2 w. Well, just another reciprocal is all you need to multiply by, and that's what we'll do to come up with the wind speed. So I'll multiply by 2 on both sides, and there it is, 40 equals w. And that would be miles per hour. So there it is. Half the answer, 40 miles an hour. The plane speed, well, just substitute. Now don't pick these tough ones here. Pick the easy ones right in here. I'm going to actually pick this one here. The 600 equals r minus 1/2 w. Because all I have to do then is do, or I could even pick this one here. This one would be even easier. 580 equals r minus w. Let's do that one. 580 equals r minus, and then you just put 40 in place of it. And it's just a one-step problem. So all I have to do there is add 40 to both sides. And we've got our answer. So add 40, and there it is. So that makes 620 miles per hour equals the rate of the plane in still air. Well, that gives an example of some of the problems you'll be seeing on tonight's homework. Here's another example of page 267, 24 through 29 all. This is asking us to graph using x and y intercepts. So remember, when we're graphing using intercepts, we want to set one of the unknowns equal to 0. So let's do the x-intercept first. We're going to set y equal to 0. So when we do that, the y cancels out, so all we're left with is 1/3 x equals 2. So you just multiply by the reciprocal, so multiply by 3, and that gives us our value of x. So x is 6. So we just go 6 spaces over. So it's 1, 2, 3, 4, 5, 6 right there, and put a dot. And then we find the y-intercept. So it's done exactly the same, except this time we need to set x equal to 0. And so we're going to set that x equal to 0, and what we've got left over when we cancel out this term is just this negative y equals 2. So from that point, just divide by that -1, and we'll have our answer, y equals -2. So there it is. Down 2 spaces, put the dot, and draw the line between those points. So there it is. There's the one. Let's take a look at this last one. This one's a little bit tougher. So what's tougher about it is that it's not in the xy intercept form. Xy intercept form, notice, has an x and y on the same side. I don't have that here. So you might end up getting the y-intercept right, but sometimes people get the wrong sign for the x-intercept if they don't move that x term over. So that's the first step I always do when I see a problem like this. And so now I've got -2 equals 1/2 y minus 2x. So from that point, we can go ahead and solve. The way we'll do that is find the x-intercept by setting y equal to 0. And so that'll cancel out your y term, left with -2 equals -2x. So all you have is just one step in this case. Divide by that -2, and we'll have the value of x. X equals 1. So just go up 1 space, or over 1 space to the right in this case, since it's an x-intercept. Put the point there. One more intercept, and then we've got the line. So we have the y-intercept, and we will now set x equal to 0. So x is 0, this cancels out. So we're left with the -2 equals 1/2 y. Well, it's an opposite operation, and we're going to multiply by the reciprocal in this case. That'll cancel out that 1/2. So multiply by 2. Multiply by 2. That leaves us with -4 equals y. So down 4 spaces, 1, 2, 3, 4, and put the dot and draw the line between those points. So that's graphing using x, y intercepts, and also a word problem involving distance, rate, and time.